Today's video is the last lesson of this unit, and it is called CPCTC. It's a lot of letters. What they stand for: this first C stands for corresponding, the P stands for parts, the next C stands for congruent, the T stands for triangles, and the last C also stands for congruent. So anytime you hear the letters CPCTC, what it stands for is corresponding parts of congruent triangles are congruent. So if you look at the picture directly below, we can see that those two triangles are congruent. The reason they're congruent is because of SAS. They've got two congruent pairs of sides and a congruent included angle. Now, what that means about those triangles is that those triangles are in fact congruent, and that's why below we have a congruence statement. Now, what that means about those triangles is that everything in those triangles is exactly the same. So not only are there the three congruencies we have marked, but there are three more congruencies that are also congruent that are not currently marked. One of them, angle A, is congruent to angle D because of CPCTC. They are corresponding parts in congruent triangles, so those angles are congruent. Angle C is congruent to angle angle F by the same reason, CPCTC. And there's one last pair of sides, which are AC and DF. Those sides are congruent by the same reason, CPCTC. So what you're going to find out about this is we can prove triangles are congruent the same way we have this entire unit. And once we have three congruences that are extra on top of the three we have to find. So if I've used angle, angle, side to prove congruence, that means that there are three more congruences that I can show about the triangles using CPCTC. And again, that stands for corresponding parts of congruent triangles are congruent. So what we're going to do in this lesson is just a bunch of proofs. And in every single one of them, the last step is going to be CPCTC. So what you're going to see about all of these proofs is that every single one of them is done the exact same way that we've done every other proof in this unit. So if you notice, when we start this particular problem, you have no congruencies given to you to start the problem. All we know is that these two segments bisect each other. That means that from A to M and M to B are congruent segments because of the definition of a bisector. We know from D to M and C to M is congruent because of definition of bisector. And we also know that we have a congruent set of angles here in the middle of the picture. They would be AMD and BMC, and they are congruent because of vertical angles theorem. So the first part of this proof is the exact same steps and process we would do normally through this unit. We're going to say that we have congruent triangles because of side, angle, side. We've got two congruent sides and an included angle. What that tells me then about this pair of triangles is everything else not marked is congruent. So in order to do the prove angle A congruent to angle B, they are corresponding parts of congruent triangles, so they are congruent. CPCTC. So if you notice about the statements and the reasons in the proof, it's the exact same process as of what we've been doing the entire unit with one step added on the end. That's really all it is, one step added on the end. The rest of the proof is the same as what we've been doing all unit. Coming down to the next one. Again, when we start this proof, notice we're given one congruence. So I'm going to mark that on the picture, one pair of congruent sides. We are also told that MP bisects the angle LMN. So if an angle is bisected, that makes two congruent angles. So my job is to figure out where those congruent angles are. Well, LMN is this angle down here at the bottom. Notice M is the middle letter, so that's that M, the vertex M. If that angle is bisected, that means I have two congruent angles. They would be named correctly angle NMP and angle LMP. And they are congruent because of the definition of bisect. If an angle is bisected, that means that we have two congruent angles. So if you look at your picture, that gives us two congruencies. They gave me one. I found a pair of congruent angles. My third congruency is this shared side down the center, MP. Now this picture is not in the shape of a parallelogram or a square or a rectangle, so I don't have to worry about changing the letters around for using the reflexive property. Now if you look at your proof, that gives you three congruencies. So as soon as I have three congruencies, I can state that I have congruent triangles. Triangle NMP and triangle LMP. Now looking at the triangle, notice the three congruencies you have. Again, it's two sides and an included angle, so that is the reason side angle side. And then notice what you're asked to prove. You're asked to prove this extra set of sides is congruent, LP and NP. Now the reason that they're congruent is because they are corresponding parts in congruent triangles, so they are also congruent. That is known as CPC-TC. Moving down, first thing I want to notice is I've got two pairs of parallel sides. So I'm going to mark those on my picture. Let's go for the easy congruence first, this side down the center. Notice this side, this picture is in the form of a parallelogram. So when I write my reflexive property, the letters do have to get switched. LJ congruent to JL. Now what I want to do is use my parallel lines to figure out, do I have any alternate interior angles congruent? The answer is yes. I have one pair here, one pair there. Those angles being angle HJL, that's the top one, and angle KLJ, that's the bottom one. And those are congruent because of alternate interior angles theorem. You have parallel lines, which means alternate interior angles are congruent. Now what you notice is the left side and the right side are also parallel, which tells you you have another set of congruent angles. That set of congruent angles are named, on the left, angle HLJ, and on the right, angle KJL. Those again are congruent because of alternate interior angles theorem. And if you look at your proof, that gives you three separate congruencies. Since I have three separate congruencies, that means that I have congruent triangles. So let's name the triangles in a congruent statement. Triangle HLJ, and to match that, triangle KJL. Looking at the things that you have marked, three congruencies, they are two angles and an included side. So that is by ASA. The last thing you're asked to prove is that this extra set of angles is congruent. Well, as soon as I see that I have congruent triangles, what that tells me is my corresponding parts are all congruent between the triangles. Well, H and K are corresponding parts in these triangles, so they are congruent because of CPC-TC. Flipping over to the back, in the next proof, again, you're given that you have parallel sides, so I'm going to mark those first. And you're also told those same sides are congruent to each other. So that's the first thing I put in my proof. MS parallel to TR. Also that MS is congruent to TR. Second thing we're going to do in our proof is start naming some congruencies. The first congruency I see are these vertical angles. So those would be angle MAS and angle TAR. And they are congruent because of vertical angles theorem, which we know as VAT, V-A-T. The second thing I'm going to notice is I have parallel lines, which means I have a set of alternate interior angles. Now, depending on which set of angles you name, it really doesn't matter which ones you say. So I'm going to say angle S and angle R. Had you said T and M instead, that would be fine. It would not be a big deal to say that set of angles instead because it's the same exact reason. The reason why is alternate interior angles theorem. Once you've proven that you've got those three congruencies, we can state that I have congruent triangles, triangle MSA and triangle TRA. And they are congruent because I have two pairs of angles and a non-included side. That would be the reason angle, angle, side, AAS. Number 5, looking at what the proof is asking me, it's asking me that A is the midpoint of MT. Well, in order to prove that, I need to know that M to A and T to A are the same. So I'm going to state that I know they are the same. The reason why? Because of CPCTC. They're corresponding parts of congruent triangles, so they are congruent. Now, how does that help me do my proof? Well, if I know that those two pieces are the same, what that tells me then is that M lies directly between the two. So I can use that last statement to say that M is the midpoint of MT because M lies directly in the middle of them. I'm sorry, A lies directly in the middle of them. So this would be A is the midpoint. Sorry. Okay, so the reason why is the definition of a midpoint. If I know that A to M and A to T are the same, then that means that A has to be the midpoint. So there's the end of my proof. Last thing we're going to talk about is something that we've talked about a little bit already, and that's overlapping triangles. So a lot of pictures are not as clear and easy to read as what you'd like. Sometimes the pictures overlap each other. So what I want you to notice about these two pictures as I slide them back and forth is that if I pull them apart, I've got two separate triangles. Notice, though, what do both triangles share? They both share angle B. So if I mark angle B as congruent to itself, when I pull the picture apart, that congruence still is taking place because it's the same angle. So what we're going to do is look at the exact same kind of picture here below for this last proof. So if I look at my picture, I've got some congruencies. Triangle ABC, I'm sorry, angle ABC and DEC are congruent. That's one given. I'm also told that CB and CE are the same. That's a second given. And I'm supposed to find a third one. That third one being this shared angle, angle C. So when I come down here, these first two statements were given, and then the next one, angle C, is congruent to itself because of the reflexive property. Anytime a side or an angle is shared between two triangles, that is using the reflexive property. So what I'm going to do is outline these two triangles so you can see what congruencies you have when I pull them apart. So here's the blue one, and then I'm going to do one in a different color. And when I pull that one apart, you can see sitting right next to each other, we have two congruent triangles, and I could slide them back and forth over the top of each other, and the picture is the same as what it was before. And so I see that this is in the form angle, side, angle, because it's two angles and an included side. So I'm going to say that I have congruence because of ASA. And then it wants you to show that AB and DE are congruent. AB and DE are the two sides up here that I'm highlighting in purple. They are corresponding parts of congruent triangles, so they are congruent. That is called CPCTC. If you have specific questions about any of these proofs, make sure you make a list of questions, make note of it on your paper so that when I ask in class, you can ask those questions.